So today we're going to start P5. You got a purple, I think it was purple last week, right? Purple worksheet. Okay. So, and people were always asking, all week long, been asking questions about P5. Well, we hadn't gotten to P5 yet. So after this week, you'll be able to do that worksheet. That purple worksheet packet will be due on Thursday, September 22nd. We collect all homework day of the summer. So that's when your chapter P test is, which is next week Thursday. Okay? Look at that one. We do need to let you know that if you haven't, so you're going to need to know your Social Security number for next week Tuesday if you haven't already registered for a dual credit class at NTC. So if you haven't taken a dual credit class yet, you need your Social Security number. If you have taken a dual credit class, you need to remember your login and your password for NTC and dual credit class, which for some people I think it's saved on your Chromebook, possibly. You also need your Chromebook next Tuesday. Okay? Okay? So those two things. And the reason is because you're actually registering as a student at NTC, and so that's why they go out with your Social Security number, so that it's you. They don't have you can't use your school ID here because school IDs are school IDs. They're just that. They're not permanent. Okay? If any of your parents have questions about it, just have them get in contact with us, and we'll explain the whole thing. Okay? So today you should have picked up a white note packet to talk about P5. That's where we'll be in. You'll have the notes throughout that note packet if you want to have that out and take notes right on there. We will continue with that packet tomorrow. We'll continue with that packet tomorrow when we deal with some more of P7 and some more of graphing and all that fun stuff. All right. So today what we're going to do is we're going to solve quadratic equations algebraic. Now you probably solved quadratic equations before when you were in Algebra 2. Okay? So a quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0. A, B, and C are real numbers with A not equal to 0 because that makes the quadratic part. If A is 0, then the ax squared term is gone. Then it's just a linear equation. So this is the standard form of a quadratic equation. Many ways to solve a quadratic equation. Okay? Today we're going to be factoring. That's one method. We are going to be completing the square. That's the second method. And we're going to be using everybody's favorite quadratic formula. That's the third method. Okay? Tomorrow we'll add in graphing. Okay? And so that's 4 methods right there. Those are your 4 most common methods to solving a quadratic equation. The answers that we get are either going to be real numbers, they can be rational, meaning they can be written as a fraction. They can be irrational, which means there's probably going to be some kind of a radical. Okay? Or they can be imaginary. Okay? Remember when we take the square root of a negative 1, or of a negative number, then we're dealing with I. Okay? Okay, we want to solve this by factoring. Okay? Now, there are many different methods to factoring. There's the X method. You know, I probably learned that one back in Algebra 1. And the reason I say that is because I just walked past the Algebra 1 classroom and they were doing like the basics, the start of the boxes and the X's and all that stuff. Okay, so there's that. There's the, for lack of a better term, I call it the butt cheeks. Okay? So 2 sets of parentheses, and then we kind of just look and see what goes where, what goes who, and all that fun stuff. So the 2 numbers that go here and here, the 2 terms, I should say, go here and there, need to multiply together to be 4x squared. Okay? So I'm going to try 4x and x. Then these 2 numbers, or these 2 terms here and here, have to multiply together to be 3. So I'm going to go 1 and 3. And then the crazy combination here and here have to add up to be that one. So this would be 1x. This would be 12x. Is there any combination from 1x and 12x that I can get 8x? No. So that means I got to check something different. So let's spin this around. Let's go 3 and 1. Now I've got 3x here in the middle, and I've got 4x on the outside. Can I get a combination to get 8x out of those 2? Ruh-roh. Now I got to go back and I got to change this one. Other combination would be 2x and 2x. Now, here in the middle, I get 6x, and on the outside, I get 2x. Any crazy combination between those to get 8? Yeah, they got to be the same, right? And they either got to be both pluses or both minuses. So in this case, because I want them both to be minuses, I'm going to go minus and minus. So the factored form of this equation would be 2x minus 3 and 2x minus 1, and that would be equal to 0. Okay. Now what we got to do is, now that we've got it in factored form, and we factor and we factor and we factor and we factor until we can't factor anymore, okay? It's my favorite F word, factoring. Okay? Right? Now what we do is we set those factors. We use something called the rational zero theorem, that if 2 things multiplied together are 0, then one or both of them have to be 0. So we set those factors to x minus 3 and 2x minus 1. We set those both equal to 0, and then we solve those. Add 3. Divide by 2. And x equals 3x. Then I go over here and I add 1. Then I divide by 2. And I get x equals 1. And those 2 combined are my solutions. The nice thing about quadratics is you're always going to get 2 solutions. Because the degree is 2. The biggest exponent is 2. Questions, comments, concerns, clarifications? Love it. Okay. When solving by factoring, after you factor the quadratic, why is it mathematically legal to set each factor to 0? And the answer is the zero product property. Okay. When 2 factors multiply might equal 0, 1, or possibly both of the factors might be on the zero product problem. You've used it many, many, many times. Probably just never. Next one is solving by completing a square. More than likely, you're okay with that, I guess, right? Fairly strong on factoring, or factoring is the one that you've done, the one that you have the most experience with. So more than likely, you're. Okay. So if I'm going to solve by completing the square, the first thing that I have to do is I have to get all of the variable terms on one side. And me, I put the numbers on the other. So I want to get all of the variables on, in this particular case, I'm going to go left with it because I want to have positive a value. Okay? So if I distribute this 2 here, then that would give me x squared minus 4x plus 11 equals 2x minus 10. Then subtract 2x. At the same time, I am going to subtract 11 from both sides. Because what that does for me then is that gives me x squared minus 6x equals negative 21. And yes, I intentionally left the gap after my 6x. Everybody with me so far? Okay. So that is step 1. I have all of my variable terms on one side of the equation. I have all my numbers on the other side of the equation. Done and done. Okay. Step 2, now we get a little funky. Now you need to identify what b is, what b divided by 2 is, and what b divided by 2 squared is. Okay. B, remember, is your linear coefficient. So that one right there is b. So my b here is negative 6. What would negative 6 divided by 2 be? Negative 3. What would negative 3 squared be? Positive 9, right? Now, here's where things get a little funky. In this gap right here is going to go this b over 2 quantity squared term. So I'm going to fill that gap in with plus 9. But what have I done? So now I got to do it to the other side. So now I got to add 9 to this side to keep that balance. Okay? Golden rule of algebra still holds. Okay? What we've done is this, actually let me highlight. This right here is now what is called a perfect square trinomial. We've just created a perfect square trinomial. Okay? And what that factors to be, here's the fun thing. This will always factor to be x minus, or x whatever, and that whatever part, this part right here. So actually, let me back up a step. It will always factor to something that looks like that. Okay? And this space right here gets filled in with that number right there. So this is x minus 3 quantity squared. And if I were to multiply out x minus 3 quantity squared, it'd be x minus 3 times x minus 3, which would be x squared minus 6x plus 9. Always happens. That's the cool thing about completing the square and doing it with where you find these, because those two numbers that you use to find it are used in the problem. Yep. Negative 21 plus 9, negative 12. Okay. Now we have completed the square. We have created a squared term equals a number. So what we can do here now is we can square root both sides. So I can square root both sides. Now, I will tell you this, because it happens all the time, okay, that when you take the square root of a number when solving, the answer is plus or minus. We're not taking just the principal root here. We're taking that plus or minus part. So over here on the left side, I just get x minus 3. On the right side, I get plus or minus. Now, over here, let's do a little sidebar action. The square root of negative 12 is going to be the square root of negative 1 times the square root of 4 times the square root of 3. Do you agree with that? The square root of negative 1 is I, the square root of 4 is 2, and the square root of 3 is just the square root of 3. So this would actually be plus or minus 2I square roots of 3. And then last but not least, we just need to solve that equation simply by adding 3 to both sides And so we get x here is equal to 3 plus or minus 2I times the square root of 3. And that gets me my two roots. The first root is 3 plus 2I squared root of 3. The second one is 3 minus 2I. But you can write it just like that. Questions, comments, concerns, clarifications? Method number 3. Quad formula. Anybody remember what the quad formula is? Yeah.
X equals negative b plus or minus square root b squared minus 4ac divided by 2a.
All over 2a. Yep. Love it. Okay. So that again is x here is going to equal opposite of b plus or minus the square root of b squared minus 4ac. All of that being over 2. In order to use said quadratic formula, it has to be equal to 0 first. Or it has to be, I should say, in standard form. So that we have our A, B, and C. What don't we have in this particular case? Or what do we need to do first? We got to get it in standard form first. So we have to subtract 5 from both sides. So then this would be that. My A value is what? 3. My B value is what? Negative 6. And my C value is negative 5. So if I'm utilizing the quadratic formula now, I would say x here is equal to, the opposite of b would be negative of negative 6 plus or minus big square root negative 6 squared minus 4 times 3 times negative 5 all over 2 times 3. Negative of negative 6 is positive 6, plus minus negative 6 squared is 36. 4 times 3 is 12, times negative 5 is negative 60. Two times 3 is 6. Square root of 96, can we simplify, or I shouldn't say simplify, yeah, simplify it is the word. Can we simplify that? What? 4 times the square root of 6? Yeah? Okay. Because 96 is 16 times 6. is that now a reducible fraction? Yeah, there's lots of even numbers in there, right? Okay. Which ones reduce? 6, 4, and 6? Which 6? The 6 inside or the 6 on the bottom? 6 on the bottom. So this one, and that one, right? So this would become 3, this would become 2, and that would become 3. Okay? So my final answer then is x is equal to 3 plus minus 2 square root of 6 all over 4. Just so you know, these two 6's do not cancel each other out. Because the top 6 has a bunch of stuff attached to it, not with multiplication.
If the square root of 96 was simplified, would it cancel out?
Nope. Good? All right. I think the P7 notes are in that package yet too. We'll come back to the P5 notes tomorrow when we deal with the graphing and all that fun stuff. We'll solve all of those same ones graphically. Okay? So we need to recall what it means to be an absolute value. Okay? An absolute value is truly, the true definition of absolute value is the distance a number is from 0 on a number line. The distance part is the part that makes it be always positive, because you can't have a negative distance. Okay? So you use the absolute value, and you just say the absolute value of 7 is 7, or the absolute value of negative 7 is 7. Okay? That's how you use it. You just make the number be positive. But the true mathematical definition is the distance a number is from 0 on the number line. Okay? So if the absolute value of x is 5, then x is going to be, so when we're solving an absolute value equation, you take the insides of the absolute value and you set it equal to the other side for your first equation. And then your second equation, you take the inside of the absolute value and you set it equal to the negative of the other side. Now for this one, it's just simply x is 5 and x is negative 5. But later on in life, we're going to have absolute value linear equations or absolute value quadratic equations, and you're going to have to do that also. Okay? So the inside equal to the other side, inside equal negative of the other side. Okay? Now, when we switch to an inequality, again, we would be concerned about 5 and negative 5. But what this right here is saying is that we want the distance, that's this part, right? The absolute value is the distance part. Distance, the number is from that, to be bigger than 5. That's how I read that. Okay? The absolute value is the distance. We want that distance to be bigger than 5. Okay? Well, where on the number line, so let me put 0 in here, where on the number line, inside those two numbers or outside those two numbers? Outside, right? Because that's where the distances are bigger. Worst case scenario, try a number. Try 0. If we plug 0 into this equation, 0, the absolute value of 0 is 0, right? Is 0 bigger than 5? No. So it can't be in there. Which means then, because we've got just a greater than, like that. And then the interval notation would be because we'd have to have both sections. In part C, what is that inequality saying?
Distance between 0 has to be less than
The distance to 0, you mean? Not between, you said between. Okay? So the distance to 0 has to be less than 5. Do we agree with that? So we want all of the numbers where the distance to 0 is less than or equal to, in this case, because I see that an equal sign equals before 2, 5. So would that be inside or outside? Inside. That would be our inside one. Now we would have filled in dots. Look like that. Interval notation for this one. Look like that. All right. So, before we even start, we want the distance, right? Absolute values of distance. We want the distance to be bigger than 5, correct? Okay? So that means we're going to have, this one's going to be going outwards. We want that distance to be bigger. Okay? So that's what our graph's going to look like at the end, right? Okay? Now we just got to figure out these two numbers right here and those two numbers, those two. Okay? So how we're going to do that is we're going to say, I'm going to set the insides 2x minus 1. I'm going to set that equal to positive 5. Then I'm going to take 2x minus 1, the insides, and I'm going to set that equal to negative 5. And when I solve those two, that's going to give me those two numbers. So if I go plus 1 all the way across, then I would have 2x equals 6, and 2x equals negative 4. If I divide by 2 all the way across, I would have x equals 3 and x equals negative 2. Yes? So those are my two numbers on my number line. So draw yourself a number line. The two numbers that you care about are negative 2 and positive 3. We want them to be in numerical order, so negative 2 would be on the left, positive 3 would be on the right, positive 3 is bigger. Okay? Am I dealing with open or closed dots? Open. There's my answer. Interval notation, it said in number 4, state it using interval notation. Well, this left one starts at negative infinity, works it all the way up to negative 2, doesn't touch negative 2. Then I've got a union with 3 going all the way to good time. Questions on all that stuff we learned today? Now, I strongly recommend that if we kind of went over the algebraic methods a little quicker today, because that should have been, that was algebra 2-ish. If you need extra practice in that, the textbook is on Canvas, and I would go into the section P5, and there's, problem sets there that have solved by factoring, solved by completing the square, and solved by quadratic formula. Okay? Right? We'll do more of them this week, but if you need more, that's where you can get more. All right? With that being said, what I'd like to do now is I'd like to take the formative. Okay? So if you could put all of your stuff away with the exception of a pencil, I do not believe that you will need a calculator, but I'm not going to stop you from using a calculator on this one.